All right, so this number 22 is an example for cross product. So torque is a cross product, and we know that it is, when we talk about torque, it's R cross F. Now remember, cross product is at a maximum when those two vectors, the R vector and the F vector in this case, or we call them A and B sometimes, it's at a maximum. The resultant vector is at a maximum when those two things are perpendicular to one another, which is why in the torque equation we use RF sine theta, because the sine of 90 degrees is 1 and the sine of either 0 or 180 degrees is 0. So that's when we're at a minimum, is when we are parallel to one another. Those two vectors are parallel to one another. So from page 53 in your book, and remember it's on page 53 because we learn about cross product way back in chapter 3 actually, but we kind of skipped over that in class just because we didn't have anything really to attach it to. Now that we're learning about torque, we have something to attach this cross product to. So from that page 53, we get that A cross B, our cross product, is equal to our A, Y, B, Z minus A, Z, B, Y, I hat, plus A, Z, B, X minus B, Z, A, X, J hat, plus AXBY minus BXAY K hat. So that's from page 53 of our book. Now, the deal here is that because R comes before F in our cross product equation, so when we write the torque equation, it's always R cross F. It's not F cross R. The R vector is our A vector in this big equation here, and the F vector is our B vector. Now, this whole thing here, that will be the torque in the X direction, because we have this whole thing and then I hat, because that's the resultant in the X direction. So when we're plugging this in then to find our Fx, which is our unknown variable, really what we're finding here is Bx. So this right here, this is our unknown right here, and this is our unknown right here. So we're just going to put Fx in for that, or just X if we want to, okay? And that's what we're solving for here. So I'm going to write this out again, but with our R cross F. So what we get here, let's do this in a different color. We get R cross F equals AY, which remember A is our R vector. So A and R go together, B and F go together. So AY will be RY, which is a -3, okay, because the J hat, of course, is our Y direction. So we get -3 times BZ, which is force in the K direction, because that's our Z, which is a -6, minus AZ, which will be this +2, times BY, which will be a +7, I hat, and then plus a AZ, and I'm going to put a bracket just to make it a little bit more pleasing to the eye, plus AZ, which will be our R vector in the K direction, so that was 2 meters, a +2, times BX, which of course is our unknown, so I'm just going to put X, minus BZ, which is a -6 newtons, because that's the Z direction, -6, times AX, which is a +2 meters. I'm just going to put 2. J hat. And then plus AX, let me erase these. So now we're adding AX, which is that +2 meters, times By, which is a negative 6 newtons. Oh, sorry, that's K, which is a positive 7, By, minus Bx, which is our unknown, times Ay, which is the J, or negative 3 direction, K hat. Okay. So now what we do here, and let me make this a little bit prettier with our brackets. There we go. That looks better. Now what we do here is we remember that here we're finding the resultant vector, which is torque. So that means that this should be torque in the x direction, this should be torque in the y direction, and this should be torque in the z direction. Okay, so for this first one, the x direction, because we already have all those numbers, we can kind of just use it as like, just checking our work, making sure we're doing this correctly. So torque in the x direction should be equal to 4 newtons times meters. Okay, so because of that, let's look and see if it's equal to 4 newton times meters. So a negative 3 times a negative 6 here, I'm looking at this whole thing right here. So 4 newton times meters should equal negative 3 times negative 6 minus 2 times 7. So here we end up getting negative 3 times negative 6. What is that? Positive 18 minus 2 times 7, which is 14. 18 minus 14 is in fact 4. So we get 4 equals 4. We are good there. I checked my work. It looks like I'm on the right track here. Okay. Now next, I'm going to do this in different colors. So let's see our y direction here. Torque in the y direction is equal to a positive 2 newton times meter. So I get 2 newton times meters is equal to 2x minus a negative 6 times 2. So here I get 2x plus 6 times 2 is 12, plus 12. So I'm going to subtract 12 from both sides. So I get a negative 10 on this side equals 2x. Divide both sides by 2, and I get x is equal to a negative 5. And remember, we're talking about a force here, so that should be negative 5 newtons. All right, so we do have an answer for our Fx now. However, let's check our work with the z direction just to make sure we're doing this correctly, okay? I'm gonna do this in blue. So now we're gonna check our work in the z direction. We get the torque in the z direction, which is equal to a negative 1 newton times meters. So negative 1 newton times meters is equal to 2 times 7, minus x times negative 3. So here we get negative 1 newton times meters equals 14 plus 3x, because we have minus a negative 3x, so plus 3x. I'm going to subtract 14 from both sides. So when I do that, I get a negative 15 newton times meter on this side equals 3x. Divide both sides by 3, and I get x is equal to negative 5 newtons. So these do match up. So that means that my Fx is negative 5 newtons. Cross product is a little bit more complicated than dot product is. Remember, dot product is at a maximum when the two vectors are parallel to one another. So you get, I hat times I hat is 1, and j hat times j hat is 1, and k hat times k hat is 1, but everything else is 0. Here it's the opposite, that I hat times I hat is 0, k hat times k hat is 0, j hat times j hat is 0. So everything else is in play, which is why we have this crazy equation that we get from page 53. Again, you're not required to memorize this crazy equation. You don't even have to really memorize how it's derived, but it is an important thing to know, the difference between the dot product and the cross product, and how to find this, how to solve this if you had this equation and you were asked to do something with that cross product equation.